Hey guys, so we're going to start off on chapter 9, which is trig identities and formulas, page 252 of your student journal, using trig identities. So you can honestly just think of trig identities as just formulas. And so on page 254 of your student journal, you have a ton, and you should definitely be referring to this page pretty frequently throughout the assignment. And so as I solve the problems in the student journal for you, I'll pull up this page to model like, oh, which one I'm going to look at and how I'm going to use it. So in exercise 1 through 4, find the values of the other 5 trig functions of theta. So it starts us off with sine, and so then it's asking us to find, cosine, secant, cosecant, tan, cotan. Since we already have sine, and cosecant is the reciprocal of sine, then we will go ahead and find cosecant first. So if you don't know what I'm talking about, I'm saying like, oh, the reciprocal identities. Sine is the reciprocal of cosecant and vice versa. Cosine is reciprocal of secant and vice versa, and then tan and cotan. So if sine of theta is 1/5, then I can go ahead and say cosecant, cosecant is 5/1, or just 5. Voila, how easy, right? Or you could write, let's see, sine of theta equals 1/cosecant theta. So I could say sine of theta, which I know is 1/5, and I can write it as 1/cosecant theta. And when we do that, then you could cross multiply. But since this one is just so obvious, then that's why I didn't do all this at the start. Because 1 times cosecant is cosecant, and 5 times 1 is 5, so cosecant equals 5, and that's it. So that was easy. Let's move on to cosine next. So I only know sine, and now I know cosecant, and I'm trying to find everything else. And one of the identities I can use knowing sine to find cosine is this one. And then if I have cosine and I need to find sine, then I can also use this one. So it says sine squared plus cosine squared equals 1. So I can go ahead and write sine squared plus cosine squared. And since the drawing is kind of wacky, or like, it's not wacky, it just is so time consuming, I'm just going to replace cosine squared with x squared, and then we'll replace it with cosine later. Equals 1. So I'm using this formula. Sine squared plus cosine squared equals 1. And 1/5 squared is 1/25. And then I will go ahead and subtract 1/25 from both sides. So I get x squared. 1 minus 1/25 is 24/25. And then we can go ahead and take the square root to get x by itself. Root 24 is 6 times 4, or the square root of 6 times 4, and 4 has a square root of 2. So we have x equals 2 root 6 over 5. And this is actually we can replace x with cosine, because x squared is cosine. X squared was cosine squared, so then x is cosine. So cosine. I'm going to skip drawing theta, but you should write it. It's just really tough with this mouse functionality. 2 root 6 over 5. And actually, we haven't made use of any of this yet. I haven't even talked about it yet. So let's talk about it. So we have pi over 2 is less than theta is less than pi. which is saying, another way of saying theta is between pi over 2 and pi. So if we look at our unit circle, pi over 2 is 90 degrees, pi is 180, and it's saying the angle is between them two, so it's in the second quadrant. And the reason why we're going to use this information at all is it tells us what's negative and what's not negative. So our y values, or our sine, is positive, and then our cosine, or our x values, are negative. So for instance, then I'll know, okay, well, cosine, if the angle is in the second quadrant, then cosine is supposed to be negative. So I'll go ahead and put a negative sign. Sine is positive, which works. And then since cosecant is the reciprocal of sine, then if sine is positive, then cosecant will also be positive. As for cosine, since the reciprocal of cosine is secant, and cosine is negative, then I could also just say that secant is negative. Okay, so we have cosine, and then we can go ahead and find secant since it's just the reciprocal of cosine. So let's do it. Reciprocal. Negative 5. Gosh darn it. Why? Sorry about that. Negative 5 over 2 root 6. But I don't want any radicals in the denominator, so I'll simplify that by multiplying by root 6 over root 6. So we have negative 5 root 6 over 2 times root 6 times root 6 is just 2 times 6, which is 12. So root 6 times root 6 is root 36, root 36 is 6, and 2 times 6 is 12. So this is our answer for secant. We found cosecant, we found cosine, we found secant. We still have tan and cotan to go. So tan which is just sine over cosine. So 1/5 sine over cosine, or negative 2 root 6 over 5. So, this is just fraction work. So to divide by fraction, you multiply by the reciprocal. So 1 times 5 is 5. 5 divided by 5 is going to be 1. And since I have a radical in the denominator, I'm going to do the same exact thing I did here, multiply by 1, which in this case is going to be root 6 over root 6. So that's tan, and then for cotan, which is a reciprocal of tan, and where can I squeeze that in? Cotan. And again, since I have a radical in the denominator, I'm going to simplify it. I don't want to get rid of it. So it'll be negative 12 root 6 over 6, or negative 12 divided by 6 is negative 2, so negative 2 root 6. So here are my 5 answers, or my 5 trig values. Cosecant is 5. Cosine is, I was going to say cosecant. Cosine is 2 root 6 over 5, or sorry, negative 2 root 6 over 5. Don't forget the negative, because in the second quadrant. Secant is negative 5 root 6 over 12. Tangent is root 6 over negative 12, or negative root 6 over 12. And then lastly, cotangent is negative 2. That's a 2 root 6. Okay, so that's number 1. Number 2, so I have cosine of theta is negative 4/5. My angle is between pi and 3 pi over 2. So pi and 3 pi over 2, which means it's somewhere in third quadrant. Not the page I want. Okay, let's find secant first, because that's easy. Secant theta is negative 4/5. As a reminder, you should be writing theta. It's just really tough for me to. I can't even write a freaking 4. So secant of theta is negative 5/4. And then we can go ahead and use this identity to find sine. So sine square, or you know what? I'm going to do what I did last time, and I'm just going to call it x. So I have x squared plus cosine squared 4/5 squared equals 1. That'll be 16 over 25. I'm going to subtract it from 1. So I'll go ahead and minus, and you end up with, let's see, negative 4 is squared is 16, so 25 minus 16 is 9. So this is going to be 9 over 25. I need to root it to get that by itself. And then I'll actually go ahead and immediately turn it into sine. And the square root of 9 over 25 is 3/5. Going back to our unit circle, since this is in third quadrant, then my sine value will be negative. So negative 3/5. Cosine, use cosine to find secant. Use cosine to find sine. I can use sine to find cosecant. Cosecant theta equals negative 5/3. And then, what do I got? Tan, which is sine over cosine. So I'll just do that over here. God, terrible. Sine over cosine, so negative 3/5 divided by negative 5/3. So dividing by a fraction, negative 3/5 times negative 3/5 is 9 over 16. So tan is 9 over 16, tan of theta is 9 over 16, and then cotan will be 16 over 9. So there's our other 5 trig, 5 values of the other trig functions. Secant is negative 5 over 4, sine is negative 3/5, cosecant is negative 5/3, tan is 9/16, and then lastly, cotan is 16 over 9. Okay. So I'm gonna leave these two because it's literally you just going through here and picking which ones are appropriate. Then I'll go here. In exercises 5 through 8, simplify the expression. So when it's telling us to simplify, it's really just asking us to rewrite it in whatever way we can. So I have tan. So tan is sine over cosine. Negative. Sine. And again, theta should be in there. It's just so cumbersome for me, so I'm not gonna, but you do. Sine over cosine divided by secant, and secant is 1 over cosine. So when we have this, we can simplify. Oh boy, sine. Oh, see that? It's going all haywire. Sine. Sine over cos. It looks like a stick figure. Pretend it's an I. Negative sine over cos times sine times cosine divided by cosine times 1. So that's just going to be 1. And I have a negative, so it's going to be negative sine theta. That's the answer for number 5. For number 6, cosine pi over 2 minus theta. Cosine pi over 2 minus theta. Oh, look at that. Cosine pi over 2 minus theta. What is that equal to? Oh, it's equal to sine. Okay, well, let's go ahead and get it in there then. Sine times, where's a 1 and a cosine squared? Well, oh wow, look, there it is. 1 and a cosine squared. So, but this says 1 minus cosine squared. Well, if I subtract cosine squared on both sides, then this is not there anymore. And then I have 1 over cosine squared on the right side. If this is not there anymore because I subtracted it, and then it becomes 1 minus cosine squared on the right side, what is on the left side? Oh, it's sine squared. So this is another way of saying sine square. And then if you multiply them, then it's just sine cubed. Okay. Let's see. Oh, okay, so it's like, oh yeah, like how am I going to bail on, like just do the mega simple ones and bail on these ones. Plus you have textbook problems anyways, so I'll work these out. We've got 2 secant squared x minus 2 tan squared x. Let's see if there's anything relating secant and tan. Okay, yeah, look. So I got 1 plus tan squared equals secant squared. And let's see how we can make that work here. So if I subtract, sorry, this says secant squared minus tan squared. In which case, so if I subtract tan squared on both sides, then it will be equal to 1. So let's see. I'm going to go ahead and start off by factoring this 2. So secant square x. After I factor it, then I can look at my identities and be like, oh, okay, well, the only identity that relates, well, is it the only one? Yeah, it's the only one that relates tan to secant is this one. And we're like, okay, well, they don't look exactly alike because this one says secant squared x minus tan squared x. So what can I do? I can subtract tan squared theta on both sides, or in this, I can subtract tan squared x on both sides. And if I do that, then on the left side of the equation, it's just 1. So really, 1 is equal to secant squared theta minus tan squared theta, or in this case, I can replace this with a 1. So 2 times 1 is just 2. And then, if you didn't get that, like honestly, just rewind by like 30 seconds and listen to me say it again, because the explanation is not going to change. I just subtracted tan squared x on both sides, right here, using this identity. And then we have, so I have, this is just 2 times 1, which is 2. Go down, sorry, negative angle identities. Tan of negative theta is equal to negative tan theta. So you can go ahead and say negative tan x multiplied by cosine, which shows that if I input an angle or the negative angle, the cosine values will be the same whether the angle is positive or negative. So if it's the same, then I'll go ahead and just say this. Actually not finished because tan is sine over cosine. So negative sine x over cosine x. Sorry, this is so painful. Negative sine x over cosine x times cosine x. Oh, what do you get when you divide something by itself? You get 1. So this is going to be negative sine x. 2 over, or negative 2, I guess, or whatever. 2 over negative sine x, same thing. And that's what we get. Okay, and then for this one, I'll leave that one up to you. But if you have any questions, then let me know, and we'll work on it. Otherwise, whew, that is section 9.1, which I understand. Oh, shoot. Let me just clear this. Fail. Okay. In exercises 9 and 10, verify the identity. So again, we're just using this to replace anything we can so that the left side of the equation is the same thing as the right side of the equation. We can change anything we want. So you know what? We are not finished, and let's just do. I'll just do number 9. So we're just looking at this piece by piece, and we're doing whatever we can to turn this into this. So the left side into the right side, or the right side into the left side. It doesn't matter. But since I already see this 1 minus cosine squared, 1 minus cosine squared is equal to sine squared, then I'm going to go ahead and do this. So again, this right here, 1 minus cosine squared, is this identity. If I subtract cosine squared on both sides, then I'm left with sine squared. So 1 minus cosine squared is equal to sine squared. So I'm going to go ahead and replace this with sine squared. Wow, okay, not bad. Over secant squared minus oh my god, it's doing it again. Okay. Okay. Okay, so I have sine over secant, sine squared over secant squared minus sine squared equals negative sine fourth, sine fourth. So, let's see. Is there anything related sine and secant? If we look here, sine and secant. Sine and secant. There is not. So what I'm going to have to do is I'm going to have to, I'm essentially making stuff up from what I can. Like anything in here is fair game. So since I know secant is the inverse of cosine, and I know that sine and cosine I might be able to relate to tan or cotan, then that's what I'm going to go ahead and try to do. So I have sine and for full disclosure, I have not looked at the answer key, so I actually don't know. So like you guys are seeing me problem solve in real time, like yeah, sometimes you just don't know. Shoot. Sometimes you just don't know and you just have to guess. And as you get the hang of this, you'll think of like, oh, you'll have a sense of like which identities are appropriate or whatever. So, sorry, sine squared over secant, which is 1 over cosine. Okay. And again, when I've done this a bunch of times throughout this video, but whenever you're dividing by a fraction, you're multiplying by the reciprocal. So this is sine squared times cosine squared over, oh my god. So sine squared times cosine squared is just sine squared cos squared minus sine square. Pretend there's a theta on all of these. Equals negative sine fourth theta. Oops. Pretend that 4 is, well, whatever. I can't. 4. 4 is an exponent. Okay, and again, I'm not really sure what my answer is going to be like, so I'm just thinking about, okay, well, if I look at this, I see that I have the same thing, so I can go ahead and try factoring it and see what that'll do for me. So I have sine square theta, but it's going to be hideous for me, so I'm not going to write it. Cosine square minus 1. Oh, I can tell it's coming together. And the reason for that is because I know there's something that relates sine squared and cosine squared in 1, so I'm going to be using that next. So let's go back to our identities. So sine squared plus cosine squared equals 1. I'm like, okay, well this says cosine squared minus 1. Like, how can I use that to help me rewrite? And so let's see, cosine squared minus 1. Well, I'm going to make it. So if I say cosine squared minus 1, that means I have to subtract the 1 on both sides, right? So if cosine squared minus 1 equals, or I would have at that point, sine squared plus cosine squared minus 1 equals 0. Because 1 minus 1 is 0. If I subtract 1 on both sides. And the reason I'm subtracting 1 by both sides is 1, just because I can, and 2, because this says cosine squared minus 1. I want there to be a cosine squared minus 1 in my identity somewhere. So if I subtract 1, I'll have sine squared plus cosine squared minus 1 equals 0. But I just want cosine squared minus 1 by itself. So here's what that'll look like. Sine squared. Yeah, and this whole time I was saying it, but I wasn't writing it. So that's kind of a fail on my part. Again, thetas are in there. It's just the writing is such a hassle for me. Subtract 1, subtract 1. And then I'm going to subtract sine squared from both sides so that on my left side of the equation, cosine squared minus 1 will be by itself. So cosine squared minus 1 equals, so 1 minus 1 is 0. 0 minus sine squared is negative sine squared theta. So now I'm at sine square theta times cosine squared minus 1 is the same thing as negative sine squared. So I can multiply by negative sine squared theta. Oh, finally, we did it. It's equal to negative sine, positive times a negative is a negative. So this is the left side. This is the right side. And it took some time, and I didn't know, or I wasn't quite sure how I was going to get there, but it's honestly just like picking, choosing. At the beginning, you're probably hoping to get lucky. But I mean, if you use your intuition a little bit, or you'll build an intuition, you kind of look at it and you're like, okay, well, oh, like sine and cosine. So sine and cosine, then I'm not going to be looking at, something like cotangent, or I'm not going to be looking at tan and secant. So finally, that is the end of the section. And so now, if you have any questions, let me know. Otherwise, get to it.